I'm going to start recording now. I wasn't recording earlier, but we are recording now. All right, so calling functions. We've talked a little bit about this, and we just looked at the open function. But functions are a group of statements that together perform one task. Now, previously to this moment, we have called many, many functions. And let me just pull up Visual Studio Code here. And we'll just look at a quick example. All right, so if I have a file, I want to save this as a Python file. I'll just save it to my desktop because I'm not going to keep it. I'll say temp.py. And then in here, to call the print function, all I have to do is write the name of the function, which is print, and then I have two parentheses. All right. Now, if I call this, that's all I have to do to call the function or invoke the function, however you want to think about it. That's all I have to do. But if I do this, watch what happens. So I'm going to say, oh, terminal, new terminal, and I'll say py temp.py. Did that not open my desktop? What's going on? cd desktop, and then up arrow. All right. That's really interesting. Look at the path it chose to run. Desktop/desktop, but I'm in just desktop. Interesting. That, oh, whoops.
So for the purge, what does that CD do?
CD is short for change directory. And so you can see at first I was in this folder on my computer, and then I said CD desktop, and then I went to the desktop. And then I said CD ... That's just a way to like go back a directory, whatever the parent directory is. And so it's just a way to navigate in here. That's really interesting. It's not running. Let me go ahead and go in here. Okay, so cse111, cse111 programs, and I'm just going to make a new file in here, and I'll call this one temp.py. I like having a workspace open, or I guess in this case, all I have open is just a folder right here, but having this folder open, I have all my code right here, and I can just right click on this folder and hit open in terminal, and it'll open it up right where that is. You can see the path here goes straight to my cse111 programs, which is the folder that I clicked on. So it makes it really easy to run this. So let me type in print right here to call our print function. Here's another command that you can check in here. dir is short for directory. So if you want to see like what is in a directory or a folder, you can just type in dir and hit enter, and it shows me everything that's in there. And one of the things that's in here is temp.py, which is what I just made. So I'm going to run temp.py and check that out. We don't have any errors. Nothing really happened, at least that we can see, but we did call that function. So we did not see anything because I didn't put anything into our print function as a parameter or as an argument. If I put something in here and hit save, hit up arrow and enter, now you can see it was able to print something. Beforehand, it just printed nothing because I gave it nothing to print, but we still ran the function. Okay, so three big things to remember here. One, the name of the function. Two, the parentheses. And three, the argument that goes into the parentheses. Now, argument and parameter, you'll hear those interchanged a lot. They do have a slight difference, but it's slight enough that most developers in the real world don't even know what the difference is. But technically speaking, an argument is when you call a function. An argument is what you put in when you call the function. So right here, this is an argument. All right. If I was going to have a function and I wanted to allow it to have an argument, then I would have to declare what's called a parameter. And like I said, these are pretty much interchangeable. Okay. But here's how you can actually make your own function. We've seen a lot before. We've seen len, we've seen max, we've seen min, we've seen input, and the list goes on and on. Ooh, we saw sum. Someone messaged me about sum earlier this week. Okay. So we've seen a lot of these functions, and all of them have several things in common. One, we did not write any of them. We have written their names to call their functions, but I have not actually seen the code for min because I didn't write the code. If I wanted to look at it, I could. It's somewhere on my computer within my Python installation. I could go and see where min was declared and what code is in there. Okay, I could look at the docs and see what kind of arguments it needs and what it will return to me. All right. And so each one of these functions has a name, has parentheses. They will have certain arguments or parameters. Okay. And they'll all do something different. Any questions up to this point on how we call or invoke functions? Okay, you should be pretty comfortable with it. Most of cse111 and all of this class so far, we've been calling these functions. Now, here's the fun part, okay? There will be many times where you want to make a function. Now let's just stop right there. Why would you want to make a new function?
So you can call it later, just like these, len, max, min.
Can you imagine if anytime I wanted to get like the minimum value in a list or something, I had to go in and like write a loop to go through an entire list and use like if statements to say, hey, if this is smaller than that, then let's save this in a temporary variable. And then once the whole loop is over, whichever one's that temporary variable, whichever one's the smallest, that's our minimum value. If I had to write that over and over and over again, programming would not be a very fun experience, in my opinion. Okay, but as it is, with this min function written right here, I could pass in a list, I could pass in a word, I could pass in a lot of different things into it, and all the code is there in one spot, and it can handle it, and I can get that minimum value back. So let's say I wanted to make a function that will give me the circumference of a circle. Okay, so does anyone remember how to do that from back in like elementary school? How do you get the circumference of a circle?
Is it 2 pi r?
I think it sounds right.
I think circumference is pi times diameter.
Yeah, sweet. Okay, so 2 times r, that'd be diameter, and then times pi. Order of operations doesn't matter because it's all multiplication. So yeah, you guys are both right. So to create a function, let's just start with the name. What would be a good name for creating a function to return the circumference of a circle?
Circle circumference.
Ooh, I like it. That sounds great. Circle circumference. If I spell things wrong, you guys, you can either just stay quiet and laugh at me, or you can tell me, which I would benefit from, okay? There's a reason why I don't teach English. Okay, so we have the name of the function, circle circumference, all right? Next thing, we have to put parentheses there, just like we would if we were calling the function. Now, at this point, it looks just like the other ones, except it's not a pretty yellow, okay? Does anybody know what we need to make it a pretty yellow?
We need def.
Yeah. Now we haven't talked about this. We are just about to talk about this right here on our slides. Okay, so the keyword to declare a new function is define, or def for short. You can't write define, it's def, but that's what it stands for. Okay, so let's come over here and I'm just going to say def space. Now check that out. 2 things happened. Let me zoom in on here. Okay, it turned yellow, just like our other ones. Let me make some of this stuff smaller. Okay, so it turned yellow. If I go back, you can see that was white. And now my program recognizes this as a function. Beforehand, it didn't. Okay, even with the parentheses there, it didn't recognize it as a function. But now I say def circle circumference, and now we have a function declaration. All right, we are not done. Okay, to call a function, it's really simple. All we have to do is just name of the function in parentheses. To write a function, we actually have to write code that's going to be executed anytime we invoke or call the function, okay? So very similar to when you have, say, like a while loop, you'll put a colon in Python, and then you'll say, you know, x plus equals 2 or something like that, all right? Very similar to that, when we create a function, we are going to put a colon and hit enter, and everything inside of this, so tabbed over 1 inside of our function after the colon, will be the code that is executed anytime you call the function. So let's practice this. I'm just going to say print, this is coming from circle circumference function. Okay. And I'm going to save this and run it. Okay, so up arrow down here. Let me get this a little bit bigger. Up arrow down here and hit enter. Ooh. All right, let's take a couple of these out. We don't need these. All right, up arrow, enter. All right, check this out. I ran it right here. We have our print statement from line 1 in our code, something in here. And that's it. Then it ended. Okay, this is coming from circle circumference function, was never printed to the screen. Why?
Because you haven't called it.
We haven't called it. Yeah, we wrote the code for it. But just like we call those other functions, I haven't called circle circumference. I've defined it. Now my Python program and VS Code recognize it as a function, but we haven't called it. So to call it, what do I have to do?
Just type the name.
Yeah, just write the name. So circle circumference, anything else? Parentheses, I saw it, Sierra, nice. Okay, so I'm gonna hit save and I'm gonna come down here and I'll do up arrow and hit enter. Look at that. Something in here from line 1 and then from line 4, we just did that. So anytime I want to tell the user or print something to the user to say this is coming from circle circumference function, all I have to do is just call this function. Okay, I could run this a bunch, hit up arrow, and look at that. Okay, every single time I have this piece of code, it will run everything after the colon inside of this function. Pretty slick, right? So let's make it actually compute circumference. All right. So what will we need? You guys gave me the formula a minute ago. What was that formula to compute the circumference of a circle?
Pi times diameter.
Perfect. Okay, so let's, for a parameter, say we need a diameter. Okay, that is a parameter. Notice a couple of things. This is not in quotation marks. All right, when we have an argument being passed into a function, when we invoke a function, it has to be like a variable name or a valid value. Okay, if I just put like diameter right here, all right, and I try to run this function, it'll give me a nice ugly error saying diameter is not defined. Now, the only difference between line 1 and line 3 is that diameter will get declared when the function is invoked. So what I mean by that is circle circumference now shows a big red line under it. It says no value for argument diameter in function call. If I put a value in here, now that red line will go away when I hit save. Oh, they all, okay. I'm like, wow, they all went away, but no, they didn't. Okay, so this one is now correct. That is a correct function call because I am supplying a value to this parameter, diameter. Without it, I would get a big error, okay, because I didn't supply that parameter like it is expecting. Now, when this runs, up here, we would get an error if we said diameter because diameter is not defined. But right here, we're not going to get an error because when the function is called on line 6, what it does is it says, okay, diameter equals 5. And it will basically declare that variable for us when we supply that argument. Okay, so me just putting a value into here. Oh yeah, do you have a question?
Yeah, so is that like defining the argument that 5 is defining it, or is that the right word?
Yeah. So like I said, parameters and arguments, it's a very technical difference. All right. And 95% of the people in the programming industry don't care. And a lot of them probably don't even know what the difference is. Okay. So a lot of time you'll just say, okay, 5 is the parameter and diameter is the parameter. Even though technically 5 is the argument that's being passed to the parameter. Okay. And when we do this, when I call circle circumference, before any of this code runs, this is going to be run in the background. Okay. You can think of it that way. Whatever argument you're supplying when you call a function, that data will be assigned to whatever variable name you declared in the function name, in the function header. Okay. So we don't have to write this because that is going to happen automatically. I'll delete that now. That'll happen automatically just when I call the function. It'll grab whatever's in the parentheses and assign whatever I have in the parentheses up here. So inside my function, when I want to access the data, the number 5 in this case, how do I do it?
Would you just use diameter?
Yep, it's as simple as that. We just gave it that variable name. Remember, it's like I'm saying diameter equals 5. Okay, now if I had written this code, I could use diameter, right? Well, that's exactly what's happening when I call circle circumference with this parameter here. It'll assign diameter the value of 5, and then I can use diameter. So let's try this. I'm just going to say print diameter. Okay, and I'm going to take all this out. We know that that won't work. I can hit save and up arrow and enter. Okay, so check that out. Nowhere am I saying print 5. Okay, but when I call circle circumference, I pass 5 in. 5 gets assigned to diameter, and then we print diameter, which has the value of 5. Which also means I'm not going to want to print 5, but I successfully used that variable from an outside source inside of this function, which is a really big deal. Because you're going to have functions all the time that need data to work. If I call a len function and don't give it a value, it'll give me an error. Be like, I can't compute the length of nothing. Okay, and it's the same thing with this. Now we're saying that circle circumference needs a diameter. And if we don't pass in a diameter, it'll give us an error. Be like, I can't do this. I don't have a diameter. But with it, we can go ahead and compute the circumference. So there are a couple of ways I could go about this. I could declare circumference and say equals diameter, and times what?
Math.py,
Math.py.
which you'll need to import math.
Ooh, good catch. Okay, so I'll say import math, and I'll hit save. And I shouldn't have any red lines. If we hadn't caught that import, we would have gotten a nice red line. Okay, what's this yellow line mean? Without hovering over it, what do you guys think the yellow one means?
Doesn't it mean that it's not getting called?
Yeah, it means it's not being used. Now I could hover over this and see unused variable circumference. Okay, the yellow lines, they could technically mean a lot of things, but they're warnings. With the yellow lines, my code will still run. I won't get any errors when I try to run my code, but it's just a warning. It's nice to have it. It's nice to see very clearly when we have unused variables, because then you could technically just take them out and simplify your code. Pulling up the chat here. Ooh, Braden, thank you. All right, so we have circumference equals diameter times math.py. And then instead of printing that random text, we'll just say print circumference. Okay, we don't have any more warning lines. We don't have any more error lines. And let's run it and see what happens. Wow, that's awesome. We could check that. I could Google it. You know, I'm sure there are lots of circumference calculators on the web. But yeah, so the nice thing is I could call this as many times as I want to, and it'll run the function real fast. Now that I have the math there, I never have to do it again. Okay, I just made my own function that was circle circumference. And anytime I want to calculate the circumference of a circle, all I have to do is just pass in a diameter, and it will return the circumference. Now, a couple of things that I don't like here. Well, let me ask you guys first. Is there anything that you guys don't like about our program? Elizabeth, go ahead.
I think you could have just said print diameter times math.py in one line. You don't need two.
Yeah, we don't need circumference. Sweet. Okay, let's check that, make sure it works. And it looks like we got the exact same thing as we did before. Awesome. Yeah, I didn't like that either. What else?
The amount of times you call circle circumference, you could just put that in a for loop.
Oh, interesting. Interesting. That's a good thought. Okay. So one thing that I'm not the biggest fan of is that these function calls, they call the function and then they don't do anything. So generally in programming, I want to split out my logic as much as possible. Now, what I mean by that is I will have a function to compute a value. And then once I have that computed value, I can go print it, or I can go use it in another function, or do some other math with it or something, right? But very rarely am I going to want to call a function that has both math and a print statement in it. Okay, so the way that I could break this up is to say, instead of print, I'm just going to say return. What does a return statement do? Does anybody know?
It returns whatever is returned away from the function so that you can access it outside the function, I
Perfect.
guess.
Yeah, no, you're exactly right. Let's look at an example of a return of function with a return statement that we have used every week this semester. Input. Please enter your name. User types in a name, and how do we get that name into our code? How do we use it?
We assign a variable to the input.
Yeah, it's as simple as that. So if I looked at this input code, it would have a bunch of stuff about printing something to the console, allowing the user to type things that I know nothing about. I just use these functions. I don't know how to actually do that. Okay, but then after that, at the very end of it, it would have a return statement that would say return name or something like that. However, it declared that variable in that function. So that return statement, whatever is there, whatever is supplied in that return statement will basically replace this entire thing. Because I'm not assigning, this string to a variable called username. No, I'm calling a function called input, and whatever the user types in, that is what is going to go to my variable called username. So right here with circle circumference, if I say return diameter times math.pi, it's going to get one of these numbers depending on what we pass in, and it will just return it. Okay, so maybe right here, I could say user diameter equals, and then I have my input and I say, please enter a diameter. Okay, we'll have a little circle calculator going on here. Okay, so again, this will return whatever the user typed and assign it to our user diameter variable. And then in here, I could say, I'll say print, and the circumference of your circle is, and I'm actually going to put an F here to make it really easy to throw a variable in here. And I'm just going to put that. The only thing I have to change is I'm going to put this user diameter right here. And then I'm going to finish up my little message. Okay. Last thing. Does anyone know what error this is going to give us if I run this?
Need an integer.
Yeah. Input always returns a string, no matter what the user types. That has to do with our return statement. It'll always be a string. So I'm going to say float just in case they have a diameter of like 3.7 or something. I'll put a float in there. All right. So input will print, please enter diameter to the screen. It'll allow the user to type. It will return that variable to this point. Everything that I have highlighted right here will be replaced by whatever the user typed when my code continues to run. It is inside of a float function. So it will get converted to a floating point number. If it is an integer, I'll just have 0.0, and that's just fine. If I want to convert it to an int later, I can. But if the user types in something with a decimal, I can work with it right now. Then the float, look at that parameter. The float function takes in an input. Well, not necessarily an input. It takes in a string generally, and it will return a number or an error if it was not able to convert the string to a number, okay? And then once it gets that value, the number, we're going to say, okay, whatever number that is, let's go ahead and put it in our variable user diameter. And then we said, okay, we're going to print the circumference of your circle is, boom, there we are calling our new function. Okay, and we're passing in the user diameter, which at this point is a floating point number. That number, whatever the user typed in, gets passed up into here. We do some math and we return. And so this whole thing will be replaced by the circumference value. when we go to print it. And then we'll print it and it'll be awesome. So I'm going to remove all this and we don't want a username. So I'm just going to hit save and let's try running it and see what happens. Please enter a diameter. Let's do 3.7. The circumference is this guy. Okay, just as a review, how would I round that? Let's say I only wanted thousandths. I wanted 3 decimal places. How would I round this?
Would that be colon 0.2f?
Okay, and where would I put that?
That would be right after user diameter.
Yeah, so if I put it right here, inside of the parentheses, we would
It'd be
basically,
outside, wouldn't it?
it'd be outside. If I put it here, we'd be rounding the diameter, which we might not want to do. And so yeah, I would do it outside after the correct value, the correct circumference has been returned. Let's say 3F. Does that look right? Let's test it. If it's wrong, it'll give us a nice big error. 3.7, and it worked. Okay. All right. Any questions on this, you guys? We just covered a lot of stuff. Any questions? Sweet. All right. If I wanted to assign this to a variable, right now we're using it just to print it, but I very easily could. All I'd have to do is just say circumference equals, and again, whatever is in the return value of this function will replace this text right here, and we'll assign it to the variable called circumference in this case. Okay. All right. Anything else you guys would change about this? Here's a question. So assuming that this is a circumference calculator that our users are going to be using, what if we wanted them to specify how much to round it by? Is that possible? I see a couple of nods and a couple of, so what do you, how would we do that? Let's go through our thought process. If you were doing this and you're like, yeah, I only need 1 decimal. Yeah, go ahead, Jake.
You could ask them how many decimal places they want, and then just put that in the, instead of .3f, it'd be dot however many they input.
Ooh, let's try it. Okay, so the user entered a diameter. I'm just going to copy that, and I'll say user precision equals, this will be an int. We don't want any decimals here. Please enter a, I'll say please enter the number of decimal places. All right, so if that's in user precision, would it work for me to just go like this? What do you guys think?
No.
No? How would I do it? Let's run it. Let's see if we get any errors when we run this and see what happens. So 3.7, preferred number of decimal places, let's say 2. Would you look at that? Okay. It might be a little surprising because this dot isn't blue anymore. It was blue, but that's a VS Code issue. Okay. If I was in a different text editor, I might not have that issue. But Python apparently doesn't have an issue with it. Okay, right now I have like nested variable stuff going on inside of my print statement, and it worked like a charm. Okay. Any questions on what we just did, or on anything that you guys see here? Okay, sweet. Well, let's go back to my slides since I haven't really touched them today. Built-in functions, how to use a function. We already talked about all of this. Types of functions, abs, float, input. Okay, notice all the return statements here. Okay, if input didn't return anything, float would give us a big error because it would say I can't float nothing. Okay, but input returns a string, gets converted into a float, and then float then returns a number, which abs can then use to get the absolute value. Same thing with round and print, string and input. We already looked at one of those. Okay, so we see all these different function calls. Somebody have a question?
Yeah, it's the abs. Does that mean it just makes it positive no matter what number it is?
Yeah, pretty much. It gets the distance from 0. So if I have -20, it'll say, hey, I am 20 values away from 0, and it'll return 20, which is a positive number. That's the most common use for the abs function, is to make it positive. Random, rand int. Notice we had to import random to use the random library. Set max time. Okay, so all these are just different functions. We've looked at all of these, I think, in the past. But these are all just here to give you guys a review of examples of when you guys have run functions. We're very used to calling functions. Okay, all of these you guys have used. And this week we're focusing on how to write functions so that you can call your own functions. Very similar to how we did when we wrote circle circumference, and we could call circle circumference to do some math. Okay. All right, modules. Math is a module. Anytime you use import, you're importing a module into your program, which expands the functionality of your program, allowing you to do things that you couldn't do before. Okay, and there are a bunch of modules. Math, CSV, array, date, time, random. We've looked at a couple of these before. There are a crazy amount of modules out there. A lot of modules. A lot of them are built into Python. So in your installation on your computer, you could just say import math, and you don't have to do anything else because math has already been downloaded on your computer and it's there in some files in the Python install. But there are like thousands, maybe even hundreds of thousands of other modules that have just been written by people like you and me who are like, you know what? I want to make a library to do every single piece of math about a circle that anyone could ever want. And they might have a calculate circumference function and a calculate something about degrees and spheres and who knows what else, you know, but they could put all of that into a module. And then if I wanted to use that, I would just have to download that module onto my computer. And then I could say import awesome circle module or whatever they called it. You can read more about the standard modules in the Python module index. How to correctly call a function. We talked about this. Name of the module in which it's located. I guess we didn't talk about that. So if I have math right here, let me just Google real quick. I'm going to say Python math module. Go into math. Let's just look at a couple of functions. Oh, math.ceil, that's a good one. Return the ceiling of x, the smallest integer greater than or equal to x. Okay, what's another good one in here? We'll just use ceil. It basically just rounds it up. Okay, so I'm going to say print math.ceil, and I'll say 5.1 or 2. Okay, so what this does, I call the function just like I did normally, but I also have the module name here. If the function is not built into Python proper, then I have to reference the module name that it's a part of, otherwise it can't find it. Just like I can't go into here and say, oh, I want to print pi. Well, it's not going to work. That's going to throw me a big undeclared error because I don't have pi declared anywhere. Pi is inside of the math module. So anytime you want to use something inside of a module, you use this dot operator to just say the name of the module and then whatever function or value you're referencing from there. All right. Three minutes left. We're good. All right. Parameter is a piece of data that a function needs in order to complete a task. We already talked about that. Math.square root's a good example of that. Examples of passing parameters. Okay, and you guys have access to these slides. I know I'm just kind of like whipping through these real fast. I feel like everything that's in these slides we kind of already talked about at least a little bit. Okay, these are just examples of different types of parameters. You notice max, look, there's like 6 parameters right here. That's totally legal. There are many functions that will take in even a lot more parameters, and that's just fine. What happens is exactly the same. If I have a function, let's say it also took, you know, time of day, or I don't know why we want the time of day in there. But if I wanted to pass in 2 pieces of data into there, when I call the function circle circumference, I would just pass in 2 things. Okay, and it'll take these as a comma delimited list. All right, and it'll say, okay, the first value gets the first value, and the second value gets the second value. Okay, and it'll just go through, split up by the commas. But I could have countless number. I could have pretty much an infinite number of parameters inside of a function. Argument is the value that is passed through a parameter into a function. So when you call a function like this, x right here is functioning as the parameter, or sorry, as the argument, and then where math.squared is defined, that is the argument in there. Passing arguments and parameters. There's one other thing that I'm looking for that I think is in here. Optional arguments, this is it, oh good. When calling a function, some arguments are optional. We haven't looked at those yet, which is why I wanted to show this to you guys. So round is a really good example. Here's the link. I just Googled Python round, okay? And so this round function has one required argument or parameter, which is a number. Can't round something if you don't give it something to round. But then it has an optional one called n digits. I can say how I want to round it. So let's look at an example of how we do that. So print also has an optional parameter, and we declare it like this. Okay, this right here would be our just this default parameter, and it allows us to add a separator between x, y, and z. If I looked, I could say math, whoops, Python round decimal. Oh, to 2 places. That sounds good. So let's look here at how they used those 2 parameters. Okay, notice we have round, number, and n digits, just like we saw in the docs. N digits is optional. And then here's how we would use it. So each one of these, we only have one parameter being placed in each one. I know that because there's no comma. If there was a comma, then I would have a second argument or parameter. If I look down here, now we can see we have our comma. We have this optional parameter, which will say to what decimal place we want to round this number to. Otherwise, it'll just default to a whole number. Okay, so the way we call it is the same way that we would call it if they were both required. But a lot of functions have things that aren't required. I don't always have to have a separate or a separator value in a print statement. In fact, I hardly ever do, but it is an optional parameter that's there. Okay, guys, I'm sorry about my rambling. We are 1 minute over, so I will let you guys go. If anyone wants to stick around for questions, I don't have a class for 14 minutes, so I have a couple minutes to answer questions. So.
Will there still be a team activity due this week? Our understanding was that that was going to be the second half of today.
Oh, yeah, I did say that, didn't I? Yes, I will go ahead and change the date on that to later this week. Today's Wednesday. Does Friday sound okay? Gives you guys the rest of the day, tomorrow and Friday to work on it. Okay, let's do that. I'll make it do Friday, at the end of the day, Friday. Sorry about that, you guys.
Thank you.
Thank you, Elizabeth. Thanks for your great questions.
Oh, can I talk to you about what I meant by confused by the quiz?
Yes, yes, please.
Okay, so I took the quiz of practicing writing something where you're supposed to test your writing skills.
Yeah.
And we wrote what we wrote was you're supposed to download a file and then take that file and use the information